Welcome to the first episode of my 1982 Yamaha XJ650 Turbo fuel injection conversion using Microsquirt. If you're looking for a well-edited video with good audio quality and fancy intro videos, this probably isn't going to be the channel for you. This is just going to be me kind of recording the progress of this build. So first off, just want to talk a little bit about the history of the bike. If you want, you can skip ahead. So back in, I don't know, 2007, 2008, around that time, my friend called me and he's like, "Hey, I got a motorcycle." And I'm like, "Oh, that's cool." He's like, "Yeah, it's like an old 80s bike and it's got a turbo on it." And I was like, they didn't make turbo bikes in the 80s. They've never made a factory turbo bike. And he's like, "I think it does. The guy that sold it to me told me it did." And I was like, "Yeah, I don't think so." So he brought it over, and sure enough, it took me a while to figure out where the turbo was. I was shocked. I was like, how do they have a carbureted turbo motorcycle in the 80s? But yeah, I didn't know anything about motorcycles back then. If you know anything about the history of this bike, Yamaha, Kawasaki, Honda, and Suzuki all were in competition with each other because turbos were cool in the 80s. And this was considered like the middle of the pack as far as quality. So anyways, he had it for a couple years. Started having issues with the carburetors gumming up, of course. Parked it at the guy who sold it to him. He parked it at his house, and he was supposed to fix it, and he wasn't in good health and just never got around to it. We talked back and forth for a couple years. It sat there, and then one day I was like, "Hey, your car needs some work, doesn't it?" And he's like, "Yeah." And I was like, "Why don't I do the timing belt and stuff on your car, and maybe you give me that bike?" And he's like, "I was actually thinking about suggesting that." So that's how I acquired it. So I got it back in 2000, I don't know, when's the tag dead? 2009. Sometime around then. Wouldn't start. Of course, the fuel check valve in the carburetors was stopped up, so I deleted that. Got it started. It wouldn't run very well. So I pulled the carburetors off, tried to clean them, put them back on. That didn't work. I didn't really know what I was doing at the time. I was kind of fresh out of college. I brought it to a local motorcycle shop. He rebuilt the carbs, and it took like a year and a half. Put the carburetors on, got it running for like probably 20-30 minutes, and then it would just shut off. I'd be going down the road, it'd shut off, have to get somebody to come get me. So I kind of gave up for several years, and I just went through this process of pulling the carburetors off, cleaning them up, putting them back on, getting the bike running. Never could get it right. People suggested that maybe the tank wasn't venting, so I should vent the tank. I tried that. That didn't help. All kinds of tips and tricks to try to get the carburetors to work right. Never could get it right. So I ended up buying a set of used carburetors, cleaned those up very meticulously, went through them with the ultrasonic cleaner and cleaned out all the parts and set the float heights, put them on, and got the bike running. Same thing. It'd run for about 30 minutes, would shut off. I got tired of the carburetors, to say the least. So I decided that I'm not going to give up on this project. I'm going to convert it to fuel injection, which is where I'm at now. I started pulling the wiring apart. The connector for the regulator, there it is melted. So when I saw that, I was like, okay, I'm just going to rewire this bike because this wiring is, you know, approaching 40 years old. Actually past 40 years old. There's a lot of unnecessary stuff on this bike that doesn't need to be there. So far, that's what I've been able to eliminate out of the harness. There's just a lot of really unnecessary stuff on here. For instance, you've got these diodes. Well, this is an old style regulator, and feel free to correct me in the comments if I'm wrong about any of this, but this is an old style rectifier regulator that used external diodes, and they wire them into the back of the fuel pump. And based on my research, that was to keep the fuel pump running only when the regulator was spinning. So this is basically your power source for the fuel pump. They did that as a safety feature so that the fuel pump would only be running when the bike was running. Modern regulators have internal diodes. I was able to get rid of that. Well, it took me forever to figure out where these diodes were because I kept pulling the harness apart, couldn't find them anywhere. Well, if you go on to Scribd or Scrib ID, whatever that website is that has manuals and stuff, they have the factory service manual. Unfortunately, I didn't find this out till later, but if you scroll down all the way to the bottom, they've got this diagram right here, which is super helpful. You've got your connector pinouts and stuff, and all your connectors and wiring colors. It's laid out very nicely. Well, there's an actual diode block, and basically the power source from the regulator would go into this diode block and power up the fuel pump. All right, moving on from there, I was able to take this factory wiring diagram and the colored wiring diagram and kind of incorporate it into the Microsquirt diagram. Here's what my wiring diagram looks like, if you can make any sense of that. So I'll show you what that looks like on the bike. We've got a fuse and relay center, and we've got our ECU relay. We've got our fuel pump relay, which powers on all these 5 fuses, and this is specifically for the ECU relay. Our turn signal flasher unit, which was originally up in the beside the gauges there. And then we've got a horn relay, and we've got a starter relay. The way this all works is these are for the fuel injectors and ignition coil and all that kind of stuff that the bike needs to run. Then we've got a secondary fuse box in the factory location. And what I did here was I split the bus bar in the back and added another power terminal right here, straight from the battery. So this is constant hot. This is key on through the key switch. This is the factory canceling unit, which I relocated from its original position, which was under the ignition control module on the right side of the bike. It's just a lot less wiring and it's a cleaner install. I didn't even know this was a thing, but apparently these bikes had auto canceling turn signals in the 80s, which is a really nice feature. And the way it works is there's a predetermined distance from the odometer that it takes for this to eliminate the ground signal to the flasher unit. Moving on, this is the factory rollover sensor, which is mounted right underneath the gauge cluster. And a lot of people eliminate these because they're doing wheelies and stuff and it can shut the bike off. I really don't think that's a good idea. The way I'm going to wire this in is it's a normally open switch, and when it tips over, it receives a ground signal. So if we take a 5-pin relay, get a little light here, we'll run the power supply for the Microsquirt to pins 30 and 87A. So those are constantly on when the relay is not energized. So if the rollover sensor provides a ground signal to the ground side of the relay coil, it will move the power source from pin 30 to 87, which will turn the Microsquirt off and power everything down should the bike roll over or get in an accident. I think the hardest part of this build is going to be getting a reliable crank signal. If you watch Dr. Motorcycle's video, he's a 36-1 missing tooth wheel, and he ended up having to eliminate every other tooth and make it a 18-1 because the size of his wheel was so small. I think it was just spinning too fast to get a reliable signal from the crank sensor. I'm going to have to modify this because the tooth profile isn't right. It's got these triangular teeth and they need to be square teeth. But I think because this is a nice 4-inch wheel, it'll fit under the factory cover. And it's going to look something like this in place of where the factory crank sensor went. I'm going to try using a Hall effect sensor versus a VR because this one is rated for 230 degrees Fahrenheit. You probably know that these things get too hot and then they don't produce a reliable signal anymore. And I'm going to put this into the factory cover somewhere and see if I can get that working. Moving on to the ignition circuit, everybody uses LS2 coils on these Microsquirts, but if you read the instruction manual, the easiest way to get a 4-cylinder engine running properly is a Volkswagen coil. This is off of like a 99 Volkswagen Beetle. It's got this nice connector here, single connector, and it's an option in the Microsquirt tuning software to use this coil. So that's the route I'm going to go for that. It's going to mount somewhere in the factory location. I've got to do a little grinding there to get some of those tabs out, and then make some coil wires down to the spark plugs. There's not a lot of videos online about doing a motorcycle fuel injection conversion. There's 3 that I can think of on YouTube, all great videos. Specifically the Dr. Motorcycle. I definitely subscribe to Dr. Motorcycle's Patreon because he's got a lot of really useful information on how he did his EFI conversion. I recommend checking him out. He does some amazing work. Originally, I was going to use 2007 Yamaha R1 throttle bodies because they line up perfectly with the factory carb boots using some adapters. But they've got this nonsense on the back of it that goes into the factory air box. I was going to have to make a plate to go on this to hook into the charge pipes. It's going to be too much. There's just too much nonsense on here as far as the idle controls, the secondary throttle valves, and I cannot find any aftermarket injectors for these throttle bodies because they use this long nose injector style. There's no information that I can find about the injector dead time and CC rating, so I kind of scrapped that idea. Found this post online of somebody that built a Yamaha XJ650 Turbo, and they use 2003 GSSXR throttle bodies. Now these are a little bit wider. I'm going to have to do a little work to individually space these apart, but it's a straight shot through to the other side. So I think that I'll be able to use the factory plenum with some silicone adapters once I get these spaced out right. And there's plenty of aftermarket support for these throttle bodies as far as the injector goes. I'm going to eliminate the secondary throttle valves, but I think that I can make this work. And plus, it's got this high idle circuit on the side, which I'll be able to fix my factory choke cable to and have a high idle. The factory plenum, if you read in the service manual, it's got this reed valve in it, and that was to keep the boost sort of built up in the intake system, and it would close it when you built boost. and I think I'm going to eliminate this because the more research I do on it, it was more of just an emissions thing, and the reed valve can flake off and go down in the intake. I think it's unnecessary, and I think I'm going to take this out and eliminate the factory 14 psi pop-off valve or pressure limiter, and just use a good boost controller to control my boost that way, because, you know, obviously we don't want to over boost or anything. And also, if we take this out, it leaves a good spot for a blow-off valve. Moving on to the starting circuit, the starting system in these bikes was just way too complicated the way they had it wired up. They had everything wired through the starter switch to where it would power off the headlight and gauges and all your accessories. Well, I was able to eliminate a lot of that using this diagram right here. So instead of running everything through the starter switch, I just used a 5-pin relay, and that's the power for all my gauges and headlight and accessories. And I added this diode in between the clutch and neutral switch, so when you engage the clutch, it doesn't turn the neutral light on, which could be kind of confusing. So everything works. I'll show you what that looks like. Bike's in neutral. When I hit the starter switch, everything goes dead, and then I release, everything's back on. I take it out of neutral. If I pull the clutch switch in, and I can hit it with my finger here, same thing, you can hear that starter relay clicking. Everything goes dead, gives power to the starter. I was able to eliminate all of the warning lights. Some of them are on right now because they're not hooked up, but side stand relay, that just goes to ground because I don't have a side stand relay. I'll just have to remember to put the kickstand up. Brake fluid, that's just a ground signal. Need to hook that up. The oil level sensor is hooked up. That's a ground signal. The battery sensor is a little bit more complicated. You have to run the factory battery level sensor to a key on power using a 2000 kilowatt ohm resistor. Did I just say kilowatt? 2000 kilo ohm resistor into a power wire, and that was able to eliminate that battery warning signal. And I've tested these bulb check warnings with the headlight and taillights hooked up. Those work great, so everything's good to go there. So if you look at my battery setup, yes, I'm using a lithium battery. I know there is some controversy about using lithium batteries on these older bikes. Well, that's because the factory regulator rectifier charges at 14.7 volts, which is too much for the lithium battery. So if you go on to Rick's Motorsports, they have a rectifier regulator specifically for lithium batteries, and it puts out 14.2 volts. I got some new alternator brushes from them. All right, I'm going to wrap things up for now. I'm going to post as many updates as I can with the progression of the progress that I made. Thanks for watching. Have a good day.